Alright guys, I thought I would do a little talk about when it's good to use pneumatics versus when it's good to use a motor. So the first example we're going to look at to kind of help explain this is actually going to be our 2020 robot L3MN or Lemon. So there's no pneumatics on this robot, and as you can see there's not a whole lot of use for pneumatics, right? Maybe we could have made a pneumatic climber, but it would have kind of been hard to reach 6 feet in the air with a pneumatic cylinder and stay this short without also having a motor or having multiple pneumatic stages. And then we could have done pneumatics to do this intake pivot, but there were a couple reasons we didn't. One was because there were no pneumatics on the bot, so why are we going to put a whole compressor and 2 tanks and solenoid block and all of that just to have this pivot when we can do it with a motor, right? The other reason we didn't go with pneumatics for this pivot is we wanted to explore doing pivots with motors because we hadn't done them in the past on any of our robots. And the third reason has to do with, well, packaging, really. There's not a whole lot of places we can throw a pneumatic cylinder in here. We could have engineered around it and done it, but it was better for us to be able to have this joint up here with nothing around it, and then be able to package our motor down underneath in our belly pan, and be able to translate that through a couple mechanical linkages. That being said, there are great reasons to do pneumatics. Our example we'll look at it for that is in 2019 for FRC Deep Space. We had this little mechanism on top of our intake. Ignore the CAD being broken, but this was our intake, and we had this guy that sat on top of it, and you notice that this is on a big 4-bar lift. But if we come back over here, if we come here, these motions are not ones that can easily be done with motors, right? All of a sudden, if we wanted these two actuations, keeping the mechanism the same at least, you'd need at least 2 motors, right, to be able to move out and then spread this apart. And 2 motors are going to get way fast, right? A motor's probably at least 1.5 pounds. Remember, this was 2019 before we had all of our fancy brushless stuff. So it would have had to be at least a bag motor, and a bag motor's pretty heavy. Now that would have added to the weight that we were already having to lift up on this big 4-bar lift, right? Yeah, that's apparently broken. On that big 4-bar lift. So it made more sense for us to go with pneumatics because they're lightweight and they're very repeatable, right? There's no tuning that has to be done in code to say, okay, I'm going to launch this out, right? There's no acceleration loop, there's none of that. It's a very simple, boom, I'm going to go out. It's going to go out by the stroke length of the cylinder every time or until it hits a hard stop. In this case, we had a hard stop. There was a big washer at the end of this where we wouldn't just break the mechanism. And same thing up here is it would go until it hit either the cylinder's in or it got stopped by something it was grabbing, right? Because if I had a hatch panel and an edge was stuck here and an edge was stuck here and it was still like that, it's going to stop, right? And it's just going to apply that constant force from the air that's being pumped into that cylinder. Another good example of that is we actually dialed down the pressure on our system a little bit with this guy. That way when this was all the way out and we hit the rocket with the hatch panel, this would kind of spring back in a little bit and add some compliance to the mechanism to where we're not damaging things further up in the system. With a motor you can do that with some crazy programming, but it's just a lot easier to do with a pneumatic cylinder. So that's kind of some of the reasons you would go with pneumatics versus a motor. If you're going to have pneumatics on the bot anyway, they're a great resource for a lot of things, including things like this that I just showed, as well as like, I need to lift the bot by 4 inches. Well, cool, grab a 4-inch pneumatic cylinder and that's a pretty easy stroke. But some of the things you have to consider when you're doing pneumatics is how much air is it going to use, and just in general, like, is it worth having the extra weight and complexity on the robot, or is it not? In 2019, we developed a small air leak that we couldn't ever find It wasn't big. It didn't affect us if we had air at the beginning of the match. It didn't affect us that much at all. But we had a finals match where the robot ended up sitting out on the field for about 20 minutes, slowly losing air pressure as we go. And then by the time we started the match, we had to wait like 30 seconds, so all of autonomous and a little bit more, for that thing to air back up to a usable state. So if you're going to do pneumatics and you have a leak, rebuild that pneumatic system until you don't have a leak, because it will lose matches. And building a robot is all about how do I make things not fail so I don't lose matches, right? Yeah, so that's basically pneumatics versus motors. Additionally, like, don't use pneumatics for things like an intake wheel. This is powered by a brushless motor up here. Well, it's a bag motor in CAD. It's brushless in real life. But don't use pneumatics for things like, I'm going to turn this continuously through a match. No. Don't use pneumatics for a thing that's like, I need to pump this 30,000 times in a match, and it'll work. Like, yeah, it'll work, but yet again, you got to think about your air consumption, because if your compressor starts running, that draws from your battery, and then if your compressor's running and you get in a pushing match with 4 to 6 drivetrain motors, you're going to start pulling your battery voltage way down, and it's not going to be a good thing, right? And that was another reason we didn't use pneumatics on this robot, is because we had a lot of motors. This robot was the most complex thing we had ever built, and it had like 12 motors, I think. Don't quite remember right off the top of my head, but if we would have had the compressor that would run at random intervals based on when we needed air, that would have been bad for us, right? I will give it this. We would have had one more thing we can do with pneumatics, because we had this adjustable hood that worked based on our climber, which is fine because we had this linear actuation back here anyway, already sorted out, and we could do that. But it would have been easier to come in with a little pneumatic cylinder and have it flip up a hood, right? Yeah. So pneumatics are good for repeatable actions that you need done consistently, that don't use that much force, but can use a constant force. They can package well, and they're lightweight, and those are the main reasons to use pneumatics.